Hi everyone, hope you like our previous videos. This video is all about the transient analysis of a CMOS inverter on the tool HSPICE. In this we have to define a netlist of the circuit. First of all we have to write down the SPICE netlist. We have to open the notepad. For example, for defining a PMOS or an NMOS, we have to define like this: MPMOS underscore 1. After the after that the drain connection, gate connection, source connection, and the body connection. After that we have to define the model name, whatever it is in the model file, model name. After that we have to define the W and L of the transistors, width and length of the transistor. W equal to whatever it is you want to write down, 180 nano, and L equal to 90 nano. Okay, so in this we are doing the transient analysis of a CMOS inverter, so I am putting a heading over here, CMOS inverter. Okay, we all know two transistors are only used in a CMOS inverter, so we are writing it down: MPMOS underscore 1. The drain connection, remember the drain connection is out, body connection is gate connection is input. Okay, for a PMOS the source is connected to VDD and the body is also connected to VDD. After that we have to write down the model name. We have to open the file which I am using the TSMC 180 nanometer technology file. So after this opening you can see the model name is NMOS for NMOS and PMOS for PMOS. Okay, so we have to write it down: PMOS. It is not case sensitive. We just have to write down the same model name, whatever it is defined in the technology file. Okay, VDD PMOS, and after that we have to define the W of the transistor. Like I am taking the 180 nanometer file, so I am defining W of a PMOS inverter is 180 nano, and length is the width is 360 nano and length is 180 nano. Okay, similarly you have to define the MNMOS underscore 1. Out and input, drain and source gate connections are same, and the source is connected to the ground of an NMOS, and body is also connected to the ground. Same NMOS. W I am taking 180 nano and length equal to 180 nano. Okay, now we have to take down the voltage sources. Write down the voltage sources. We needed two voltage sources: one is the VDD and second one is the input. Okay, so to define a voltage source we have to write down V voltage source underscore 1, and VDD, it has two connections, plus and minus. We have to define plus and minus connections. Okay, so plus connection we have to write down VDD, and minus connection is ground. These are the two connections. Now we have to define the type of the voltage source we are taking. VDD is always is our DC type. Magnitude is 1.8. Okay, so next is V voltage source underscore 2. Input. Okay, ground. Now I'm taking the pulse form of the signal. We have to write down the lowest voltage, 0 volts, 1.8 volts. After that we have to define the delay. We are taking 0. After that 0.1 nano I am taking the rise time. 0.1 nano is the fall time. Okay, and after that I'm taking the pulse width is 1.9 nano and 4 nano. 4 nano is the period here, and 1.9 is the pulse width. After adding the rise time and fall time, we get the desired period what is taken here in it. Okay, now we are doing a transient analysis. You have to write down the dot tran. After that, the step size 1 nano, and I want the simulation to end after 10 nanoseconds. Okay, it will end at 10 nanoseconds, and after in 10 nanoseconds. After this, we have to include the library file, technology file, whatever. In this, I'm taking this TSMC 190. You have to select it down, copy it, and paste it here. Okay. After that, at the end, we have to write down dot end, and now we have to save the file. On saving this file, you have to write down the whatever name you want to write. After that, you have to write down the .sp. .sp is the spice format. We want this file to save in the spice format. So .sp is a important thing you should remember. Okay. After that, save. We can close it down. Open that folder. Okay, here it is. Going back to the tool, we have open the design file, inverter spice, simulate it. You can see various 4-5 files are generated here. .ls file is the file where we can see the errors of the netlist. If the netlist you have written got some errors in this, you can see it in here. If it is not, it is completely taken out, completely simulated here. Okay, and also we can see the results parameters we take out in the netlist, delay, power, whatever it is. Okay, tool AV and waves is waveform editor. Okay, there it is. Have to select down these 4 voltages current. We can also see the different voltages current. Okay, now we have to see the inverter only. Voltages can show this. Double click on this and double click on this. You can see the voltages here. To separate the charts, you have to go to the Windows stack and overlay mode and click it. You can easily see this is the input, yellow color, and red color is the output. Okay, you can easily see that the waveform is inverted. This is how you can practice more and hope practice more on this thing, and you will get a hand on good expertise on this thing. Okay, that's all guys. Hope you like it, and hope you like this and subscribe our channel. Thank you very much.